Okay, this video demo is going to be on the name groove. And if you look on the drawing, on the left side view, this would be the front, this would be the right, this would be the left. The left side view has a little oval shape there, and it says name. And you'll be putting your name however you want to write it is fine, just so it's going to identify your part to you. First name, last name, mom's name, doesn't matter. The only thing I do ask on the name is that use the same name for all the projects you do in this class. So think about that. And then if I go over here to the right side notes, it gives me the material size. And then number 2, it says the name groove is a 250 thousandths slot times 20 thousandths deep. So you can see the little radius on the end gives you an idea of what that is. The one unique thing about the name groove on the drawing is there's no center line down the drawing. So it kind of doesn't matter where you have this position in the thickness of the part. But I'm going to show you kind of a quick way how to use the side of the edge finder or the side of the end mill like as an edge finder in a real quick operation here. And then it shows a 20 thousandths depth. Now, there's a workbench between the saws. And on that workbench we have a set of letters here. And these measure, you can actually take your caliper and measure each one of these. And these particular ones measure 250 thousandths thick. Of course, that's the shank of this. The letter itself might measure a little bit smaller, but for purposes of measuring the length of the groove, the name groove you're going to do, I can just count the letters and multiply by 250 thousandths. So if I use 6 letters, that's going to be 1 inch. No, it's going to, yeah, 1.5 inches long. So if I have these stacked together like this is just 3, but if I measure this, this will be 750 thousandths. So I would count the number of letters I'm going to use. I would maybe add another 250 thousandths on each side so I have some clearance, and that would give me the value for the length of my name groove. So what I'm going to do, once I've determined that, I'm going to determine which side I'm going to put it on. On the drawing, it does show the steel stamp on a particular side. So this bottom left hole is a coarse thread. Is the small coarse thread. The bottom right is the small fine thread. And this would be the side I would steel stamp. So because of that, if I look at my drawing, I would orient the part like this based on my drawing, and I would turn the part up in this direction. Therefore, the name groove would be on this side of my part. So that's really important because you can be marked down for that as well. Make sure you're orienting the name groove on the correct side. So once I've determined that, I'm going to take my Sharpie and my steel rule. I know this is close to 3 inch, so I can actually just go ahead and mark, let's say the 1.5 inch line in the middle here is right here. And I know based on the amount of letters I'm going to use, I'm going to use 6 letters. I'm going to add another 250 thousandths clearance on both sides. So I'm going to make my name groove 1 inch 750 thousandths. So what that means is I'm going to divide that number in half, and I'm going to try and put a mark on this side of the middle line and this side of the middle line. So if I kind of go here like this, I can go, actually I like using the tenths one. I can go to here, and I can flip it around. It's a little easier for me holding it this way. I can also go here. So these are just basic simple marks for the middle and both sides that I'm going to use to run my end mill back and forth. I'm going to make sure my vise is clean, my part's completely deburred, and I'm going to set this in there so it's sitting on the middle part of my mill vise here in the middle is open. So I'm going to make sure I'm sitting flat on the right or the left side here. I'm going to clamp this in there. And if it's deburring clean, I don't really need to pound on this, although you could hit this with a hammer once. And the name groove shows on the drawing, it's 250 thousandths diameter slot. So I'm going to get a 250 thousandths end mill. I have a wood box here with some tooling. And I'm going to measure this diameter. The drills I measure like this along the shank because the shank matches the diameter of the drill. But on the end mills, I like to measure on the very tip and kind of rotate this and make sure I get to the high point. This one measures 250 thousandths diameter. The shank is actually a 3/8 shank. So I've tightened the 3/8 end mill holder in here. I'm going to go ahead and install the end mill. I'm going to bring actually I'm not going to do this quite yet as far as the quill stop. I'm going to bring this down, and I'm going to bring my end mill over. To where my end mill is on the back side of my part here, and just above the solid jaw without having been on the quill stop. I'm going to lock this in place. I'll move it down just a little bit more. I'm going to rotate my end mill so I know that the flute on my end mill is at the high point and tangent. I'm using a 2-flute end mill, so there's a lot of clearance in there. I want to make sure the cutting edge of my end mill is at the high point against the back of my tool here, or back of my part. What I'm going to do is I'm going to use a piece of paper. And I'm going to kind of look at this, get it kind of close, and then I'm going to wedge this piece of paper in here between the end mill and my part. And I'm going to move this back and forth like this, and slowly move my part towards my end mill 1/1000th at a time until the end mill drags the paper between the cutting edge of my end mill and I ripped the sheet, so I'm pretty tight in there, but I didn't really gouge the material. So now the cutting edge of my end mill is up against the edge of my part here, okay? I'm basically using my end mill in this instance as an edge finder. And instead of having the tip run eccentric from the shank of the edge finder, I'm using my piece of paper. Once it pushes the piece of paper against the edge of the part, and I keep moving it back and forth, it'll rip the paper and I stop feeding. So now that I know that my 1/4 inch end mill is against the edge of my part, I'm going to bring this up. I'm going to zero my cross slide micrometer dial, and I'm not going to go backwards. I'm going to keep moving towards my end mill, and I'm going to move the radius of the cutter that I just touched off on. This is a 250 thousandths diameter cutter, so I'm going to move this 125 thousandths. Now I know that the spindle center line in this direction is directly in line with the edge of my part. I'm going to unlock the collar on the micrometer dial on my cross slide, or my saddle. It's called a cross slide on the lathe. Here we call this the saddle. I'm going to lock it at 0, and now I'm going to move the center line of my spindle to the center line of my part. So I'm going to measure my part. I measure this part at 375 thousandths. I'm going to divide that in half, and I'm going to not move backwards. I don't want to get into the backlash. I'm going to keep moving in the same direction. I'm going to move 187 thousandths 5/10. And I'm not going to bother zeroing this, but I can bring this down and look at this, and I can see, if I look to the side, that it looks like it will cut evenly on both sides. So that's how I'm using the edge of the end mill as an edge finder. You can do this with an edge finder and then switch the edge finder out with the solid end mill holder. Never use a drill chuck to hold a solid end mill holder. A drill chuck should be installed and used only for center cutting tools, like a spot drill, a reamer, a tap. Never use it on an end mill. And you know that because there's a weld-in shank there. Okay? So from here, I know I'm on the center. I have the marks for my length, for my table movement. I'm going to bring my end mill down, and I'm going to bring my adjustable stop up. And to where I'm not cutting on the part. I'm going to bring this down. There's still clearance on the part here. So, this all looks good. I can see my marks here. I'm going to start my spindle. And I'm going to slowly watch this as I slowly bring the table up, using my table feed crank up. And once I see and hear it cut on that face, I'm going to stop. And keep adjusting the table feed. Oh. From here, I'm going to turn off my spindle, bring my quill up, and I might be a couple thousandths deep, but that's fine. I don't necessarily have to zero my table feed, because all I really need is 20 thousandths feet. So I'm just going to count 20 lines here. 5, 10, 15, 20. And that's it. And this is maybe one of the easiest cuts we'll make here. Is I'm going to start my spindle. Let's see, make sure I have this where you can see it. It's going on this side. I'm going to bring my end mill down. It's going to puncture the material about 20 thousandths. So and I'm going to feed to my black Sharpie line on that side and my black Sharpie line on this side. Feed towards the middle, and I can actually release the end mill while it spins, and the spindle pressure will bring it up. That's, usually not common that we would do that. So this actually looks pretty good. You might want to measure that and make sure you have enough room for your name. But that is the name groove operation. And you can see there, I can still see my marks, but I'm sure there's plenty of room. This one doesn't look quite centered, but I just did that as an example for this demo.